Welcome to my presentation. In this presentation, let us try to find the area of a parallelogram, and I have started the figure here and then I will explain this as we go. If the vectors given to us are a as equal to negative 3i plus 4j plus k, and if we were to plot it on this XYZ coordinate system, the way to do that is as follows. I'm going to pick these different colors here. Negative 3i, we're going to travel three negative units on the negative x-axis, 1, 2, 3 on the negative x-axis, 4 units on the positive y-axis, that would be 4 units here, 1, 2, 3, 4, and then 1 unit on the positive z-axis, so therefore we go up, and this is the line. The green line is indicating the vector A. Vector A is therefore negative 3i plus 4j plus k, like that. And if vector B is given to us, as 0i minus 2j plus 6k, and the way to plot it on this XYZ coordinate system is as follows. There is no x, so we will not have any x ordinate, and there is going to be a y ordinate, and we're going to go 2 units on the negative y-axis, and then we're going to rise 6 units on the positive z-axis. So that is the point where the second vector is going to terminate. So I've indicated that by a green line, and then I've also named that line or that vector with the corresponding components in there. Vector B is equal to 0i minus 2j plus 6k. Now that we have all the information, we want to find the area of the parallelogram given these two vectors. The way to complete this figure is as follows. A parallelogram, I'm going to draw a small figure here, is a figure like this. A parallelogram looks like a skewed rectangle. 2 long sides are equal and 2 short sides are equal, and the interior angles, the opposite interior angles are equal. This angle is equal to that angle, and this angle is equal to that angle. Now, with the information given to us with vector A and vector B, if we were to draw another line parallel to vector A starting from the terminal point of vector B, we can do it this way. We can draw a line that way, and then from the terminal point of A, if we were to draw a parallel line to vector A, we can draw it like that. So that will make it into a parallelogram. And if I were to pick another color, and if I were to hatch this area, this is the region we want to look at, and we want to find the area of that parallelogram. And the way to do that is as follows. We have looked at some of the properties related to area of parallelogram using vectors, and the way to do that is as follows. Area is given to us as the cross product of vector A times vector B, and we're going to take the magnitude of that product. So as a first step, let us try to find the cross product between vector A and vector B. And to do that, this is how we're going to proceed. Vector A, the components are given to us as negative 3i plus 4j plus k, and then we're going to cross that with vector B, 0i minus 2j plus 6k. And to do this, we will use our determinants knowledge to be able to do this. So we can write I, j, k as the first row, and then on the second and third row we will pick the coefficients of I, j, and k of vectors A and B. The coefficient of I for the first vector is negative 3, coefficient of j is 4, coefficient of k is 1. For vector b, the coefficients of I are 0, coefficient of j is -2, and the coefficient of k is 6. If we take the determinant of this, we should be able to find the value of A cross B. So we will travel along the first row, and the sign convention we're going to follow is positive, negative, positive. So that is how we want to arrange that. And once we expand this, this is how it's going to expand. I, the minor of that is going to be 4, 1, -2, 6, minus j, the minor of that is going to be -3, 1, 0, and 6, and then plus k, the minor of that will be -3, 4, 0, and -2. And therefore, when we simplify this, it's going to be I, 4 times 6 is 24, minus 2 times 1 is -2, times minus will be +2, minus j times 6 times 3 is 18 with a negative sign, minus 0 times 1 is 0, plus k times -3 times -2 is +6, minus 4 times 0 is 0. So therefore we can write this one as 24 plus 2 is 26i, -18 times -j is +18j, plus 6 minus 0 is 6, therefore 6k. So we have all that information. What we need to now do is find the area of this parallelogram. The area of the parallelogram is given to us. The area is given to us as the magnitude of vector A cross vector B. We have already found the value of A cross B, which is that information there, and therefore now that we want to find the magnitude of that, we're going to take this individual components and raise it to the power of 2. 26 raised to the power of let me write this a little bit more clear. So 26 raised to the power of 2 plus 18 raised to the power of 2 plus 6 raised to the power of 2, and then all of that under the radical sign. So when we simplify all of that, it is going to come out as 1036. So when we use our scientific calculators and try to find the square root of 1036, it is going to come out as 32.19 square units. The area is always measured in terms of square units. So the area of a parallelogram is 32.19 square units. So this is the way we can find application problems. In this particular case, we are trying to find the area of a parallelogram using vectors. In my next presentation, we shall look at some more examples related to applications of vectors in 3 dimensions.